Hello everyone, I'm Frank and welcome to Frank Puzzles. In the month of November, I'm going to be uploading 3 videos every day. Two that are going to be average to easy or very easy difficulty level, and one that's going to be average or harder difficulty level. So this is today's very hard puzzle. So we'll see how long this takes. This might take a while. I looked at the rules, or the rule, and it looks pretty challenging. Anyways, if you like to let's just get to the rules. It's called Something Something Lines by Falula? I think it's Falula. Maybe it's Faluta. I can't really read that. That font is really weird. Anyways, and here are the rules. Sudoku. Place the digits 1 to 9 each once in every row, every column, and 3x3 box. Lines. Each line is at least one of the following: a region sum line, a row sum line, or a column sum line. That is, it has the same sum in either all boxes, all rows, or all columns it visits. Which rule applies to which line must be deduced. And that's pretty crazy. That's a lot of that's a lot. um so what that means is, that's actually interesting. How does that work in, like, is it an actual region sum line? So a normal region sum line, it usually means that if the line is cut up by a box border, so one of these darker lines, then usually it's considered different regions. I'm not sure if that's what he means there, because so unfortunately there is one where basically, obviously, we would rule this out as a region sum line if it were normal region sum values, right? Because this would have to be a different region from this, because the box board cuts the line in 2 places. But I don't know if that's the case. I don't think it is, because he says specifically it has the same sum in either all boxes, all rows, or all columns it visits. I'm a little scared that that basically means, like, yeah, that's a little scary, because it could mean that basically, if the region sum line rule is the normal region sum line rule, we have a lot of information on this line. Yeah. Anyways, this is sort of solving it. Um. Yeah. So region sum line, I don't know whether it means that in this line, these 2 digits equals the same as these 3 digits, which equals the same as this digit. Normally, in region sum lines, it would be this digit must equal this digit, which must equal that digit, which must equal those 2 digits, which must equal that digit, because the line gets divided that way. But the way that he describes it in his rules, it says either all boxes, the same sum in either all boxes, all rows, or all columns. So I don't know which way it is. And for a row sum line, obviously it would be these 2 equals the same as these 2, which would equal the same as these 2. And if it's a column sum line, then it would be this one is equal to the same as this one, which is equal to the same as these 3, which is equal to the same as that, right? Because then you have the same sum is in all boxes, rows, or columns. So the columns would be here, which shows you why it would be that. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. I don't know how long this is going to take because this might. Uh, we already have that question about that rule specifically, whether it's a normal region sum line or whether it's what he specifically states. I'm pretty sure it's what he specifically states. So my guess is that it's these two boxes must equal what these three boxes must equal this box or this cell. If it's a region sum line. Obviously, it could be not a region sum line, right? Anyways, those are the rules. If you there's going to be a link in the description, and now I'm going to get started. Let's go. Okay. This is obviously not a okay, so what are we going to label things? So we know there's at a minimum a region sum or a row sum or a column sum, right? So what that means then is we should color the even if it's multiple ones, it doesn't matter, right? Because the constraints are the constraints will only really factor for one of them. It doesn't matter about like if it has two or three, right? Okay. So we should color, okay, we're going to color things green for region sum. Actually, maybe it should be blue. Blue for region sum. We're going to be green for row sum and red for column sum. I don't know. It's just, yeah. So this cannot be region sum. We know that can't be region sum because that would have to be the same as that, which would have to be the same as that. So it's either row. So this is either row or column sum. We don't know which. This could still be region sum here. This cannot be column sum because then this would be the same as that. So this is either row sum or region sum. Same with this. This is either row sum or region sum. We don't have any information about this, right? These two could be the same as these two, which could be the same as these two, which could be the same as those two. That could be the same as that, could be the same as that, could be the same as that, could be the same as that. These three could equal those three, which could equal those two. Those are all valid. This could be anything. Oh, but we do know this is the same as that. So let's mark that we know these two are the same for sure. Because whether it's row, in fact, actually, it fits all of them. So this is one of the ones that is all three, right? It's a region sum, it's a row sum, and it's a column sum because it's just two digits. And they're the same digit, though. So that means the yellow has to be one of those three. We don't know which. This is, yeah, a little bit, we don't know. It could be 2 equals 3 equals 1. It could be 1 equals 1 equals 3 equals 1. So either way, this has to be 6, 7, 8, or 9, right? If it's a row, oh no. If it's a row, it doesn't work that way. If this is row, this is the same as that, which would equal that. If it's column, this is the same as that, which would equal that, and it's the same as that. Okay, we don't have much about this information too. Oh, it cannot be column, right? This is the same as that, which is the same as that, and that doesn't work for column. So this is also blue. This is also region sum, or it's row. Interesting. Either way, this digit has to be either this one if it's region sum, or this one if it's row sum. Again, it cannot be column sum, right? Because then you'd have 3. So we know then that this digit must equal either this or this. So it cannot be this one, obviously. It can't be that because it sees all. It can't be this because it sees all three of those. So if it's this one, hmm, that is interesting. Anyways, that doesn't really tell us much. Can this be row one? Which no, this can't be row. If this was row, this would be equal to that. So this is region sum or it's column. Ugh. Interesting. So for this one, we know either this is 6, 7, 8, 9, or this is 6, 7, 8, 9. We don't know which though, right? Hmm. Okay, so what happens if this is a region sum line, right? This has to be the same as that, which means it cannot be any of those. It can't be the yellow. It could be one of these three. Say this was a row sum line, right? Then this digit would have to equal one of those three. Would have to equal all three of those. So it's 6, 7, 8, and 9. It could not be this. It can't be yellow. It can't be this. It cannot be that. Well, it could technically be that, right? Okay, so say this was a row sum line, and say it added up to 6, right? This can't be 6. Oh, what if it's 9? If this is 9, it cannot be any of these. It could be that one. It can't be yellow. Oh, this can't be 9. If it's a row sum line and this is a 9, it cannot be. Right? Where is it going to be in box 5? Well, it can't be yellow because we know those two are there, and so it can't be that one. It can't be any of these because it sees those two. Okay, so it sees all three of these. It can't be the yellow. It can't be this because these two have to add up. These three have to add up to this. Um, it can't be that because it's either part of the 3 rows or the 3 in the region, and that can mean never be 9. Okay. Yeah, where is that number? So where is this, right? This specific digit cannot be any of these two. Assuming it's row, or yeah, assuming it's a row sum line, it cannot be any of those two, and say it's not 6. So if it's 7 or above, it cannot be either of those two, right? Because uh, those three would have to add up to that digit. Um, Even if it's a regular, say it's a region sum line, even. Oh no, you could have 7 or 8. You just can't have 9, right? If this isn't okay, so yeah, if it's an 8, it could be here, right? This would be a region sum line. This would be 9. This could be 1 8. Okay, so yeah, where is the 9? Actually, where is the 9 in box 5? Where could it be? It cannot be these two because those both are part of either a row sum line or a region sum line that add up to one digit. So these cannot be 9. This could be a 9, but then that can't be a 9 if that's the case. This could be a 9. So these two could be 9s. This cannot be a 9. Neither of those two could be a 9 because it's either part of a region sum or a column sum line. This could be 9. These two cannot be part of a 9 because it would also be part of 3 for a region sum line or 3 for a row sum line and 2 for a region sum line. So it could not be 9. So the 9 is either here or it's here or it's here. If it's here, this has to be a region sum line, and then that's 9 too, right? So this could not be 9. And that can't be 9. If this is 9, this would have to be a row sum line. Hmm. Okay, that's interesting. I don't know what that really tells us, but we do know that it could be 2, right? It could be a row sum line. 2, 2, and 2. So that doesn't actually give us much information there either. Hmm. Column sum line seems rather weird. If this is a column sum line, then we know that this is equal to this, which is equal to that. I mean, that seems possible. We would know that that would have to be 1. One of these 3 would have to be 1. One of these 6. Cannot be this one. So one of these 6. One of these 6. I don't think that really tells us very much. Unfortunately, I think, yeah, we have to keep going with where the 9 could be, right? Okay, so if this is a 9, that means this has to be a region sum line. And then these two would add up to 9, and this would have to be 9. So this could not be 9. Right? If this is a 9, this can't be 9 either. If this is, if this is a 9, this can't be 9. Well, we've shown that this cannot be a 9, period, then. I don't know what that tells us, though. Okay, these have to be 1 through 6. Because it's either part of 3 here that add up to 1 digit, or part of 3 cells here that add up to 1 digit. We don't know which, though. This could be part of 3 that add up to 1 digit. Oh, that's interesting. Not sure what that really tells us. Anyways, we have a 7 and an 8 somewhere here, too. If this is a row or column one, if it's a row, this would equal those 3, which would equal that, which would equal those 2. This would equal those, if it's a column, this would equal those 3, which would equal that, which would equal those 2. Let me pause. I need to go to the bathroom for a little bit. And we're back. Okay. So, okay, so can this ever be 1? Can this ever be 8? I don't think so, right? If this is 1 and 8, this would have to be 9. But the problem is, if this is 9, that can't be 9, that can't be 9, so this would have to be the 9. But this being a 9 would mean this is a region sum, so therefore that's a 9, and there you have a contradiction. So this can never be 8. It could, I think, be 7, though. Right? No 8. No 8. What if it's 1, 7? If it's 1, 7, this would have to be 8. This would be 8. Oh. I don't know if it could be 1, 7 either. If it's 1, 7, this is 8 and that's 8. So that eliminates here being 8 and that being 8. So this would have to be 1, 8. Okay, let's just go through the scenario then. If this is 1, 7, this would have to be 8. This would have to be 8. None of these could be 8. So the yellow can't be 8, that can't be 8, that can't be 8. Therefore, this has to be 8. Which is 1, 8. Which is not possible. So it can't be 1, 7 either. So this cannot be 1. This cannot be 7, 8, or 9 here either. This can't be 7, 8, or 9 either. Can this be 1, 8? If this is 1, 8, then this has to be... Oh, no. This has to be 9, and that has to be 9. And that eliminates all the possibilities for 9. So this can't be 1, 8 either. So 8 also has to be one of these three. Interesting. Can this be 1, 7 is actually another question then, right? It can't be 2, 7 because then you have the same problem of both of these being 9, right? But can this be 1, 7? No, it can't be 1, 7 either. So this, because that would have to be 8, and then that would have to be 8. Because it would have to be a region sum line, and it would eliminate all the possibilities for 8. So this can't be 7 either. This has to be 1 through 6 also. So these are 7, 8, and 9. Interesting. And therefore, this cannot be a region sum line. Because the 7 can never be with two other digits to add up to another, with two other cells to add up another digit if they're unique. Therefore, this is a row sum line. So this is a row sum line, and 7, 8, or 9. So this has to be equal to 1 through 6. We don't know anything about this. This could still be a row sum line, right? So if it's 7, this would have to be 9 and 9. So, okay, that's pretty cool. What does this tell us though? I don't know. Hmm. This can never be 9 again, right? If this is 9, it can't be yellow. It eliminates that one. If that would be 9, it would have to be the same as that. So it cannot be 9. So obviously it could be 1, it can't be 1 through 6. Either it's a row, in which case it's 6, 7, or 8, right? Because these three digits would have to, these three cells would have to add up to 6, 7, or 8 because they're unique digits. Or it could be 3 through 8. It just can't be 9 right now. So this is 3 through 8. This can't be 9 either. The problem, okay, so this could actually be 8. In which case, this would be 1, this would be 9 and 9, right? And that would be a row sum line. So that's possible. So this could actually be 2 and 6. So that's valid. It just couldn't be 1 and 7, right? Because we know 1 and 7 has to add up to 8. This would be 8. This would be 8. Um, hmm. It can't be 2 and 6. If this is 2 and 6, that becomes 8, and that becomes 8, which eliminates 8 from being there, 8 from being there, and 8 from being there. So 8 cannot be anywhere there in box 5. So this cannot be 2 and 6. It can't be 1, 2, 6 because it can't be 9 anymore, right? This can never be 9. So for a row sum line, that wouldn't work. We tried 2, 6 for the region sum line. Same problem with 1 and 6, right? And 3 and 6 is right out because it can't add up to 9. So it can't be 1 and 6 either because it's the same problem, right? Then this has to be 7. This has to be 7. It can't be 1, 2, and 6. So this 7 would mean neither of these were 7. That's not 7. So none of those could be 7. So this can't be 6. The 6 could be here, right? It could be 6, 1, 2. So this is equal to those 3. Can this ever be 6? If it's 1, 2, 6, this is 9. That's 9. So this would have to be 9. So that's possible. So this one could actually be 6, right? We just know this can't be 6, right? Because this can't be 1, 2, and 6 because that would add up to 9. But this could be 1, 2, 6, and then this adds up to 9. And then this would be 9, and that would be 9. What about this being 6? One thing it cannot be is that this cannot be a region sum line with a 6. If it's 3, 6, this would be 9 and 9. The 9s would be eliminated, box 5. If it's 2 and 6, this would be 8 and 8, and the 8s would be eliminated in box 5. If you have 1 and 6, this would be, again, 7 and 7. The 7s would be eliminated in box 5. Now, what if the 6s were here? Well, we know, okay, so then this is 1, 2, 6. This would have to be 9. So you would have 7 and 8 and 7 or 8. That seems reasonable. Interesting. Okay, hold up. One of these has to be 6, obviously, right? If this is 6, it cannot be as part of a region sum line. Because if it's 1, 6, 2, 6, or 3, 6, you would have a 7, 8, and 9 be here. So it would have to be part of a 1, 2, 6, which would mean this is a 9, which would mean that's 9. If this is 6, it could also, we already know it's part of a row sum line. So if this is 6, this has to be 9. So this can never be 9. So either this is 9 or this is 9, right? If this is a 9, this has to be a region sum line. And this is a 9. If this is the 9, this would have to be 1, 2, 6. Hold up. So if this is 6, this is 1, 2, 6, right? This is 9, so this can't be 9. I guess it could be like 1, 5. So if this is 6, this is 1 and 2. If this is 6, it's a 1 and 2. Hmm. Hmm. So if this is 6, it has to be with 1 and 2. If this is 6, it has to be with 1 and 2. Uh, Therefore, this can never be 3. Because if this is 3, that requires this to be a region subline, and it would have to be 1 and 2. And we know at least one of the 1 or 2s is here. So this cannot be 3. Right. It's either a region sum or it's a row sum. So this is, yeah. So if this is 9, obviously that has to be 9. This has to add up to 9. So 9 cannot be here, 9 cannot be here. This becomes 7, 8, 7, 8. That doesn't really tell us very much. If this is 9, this becomes 1, 2, 6, because this cannot be 6 anymore. Okay, so what does that mean then? If this is 9, this becomes 1, 2, 6. This can't be the 6. This can't be 1, 2. 1, 2, or 6. This can't be 9. This can't be 9. I guess that could be 9? Maybe. So this would be 3, 4, 5, 6, no 6, 7, 8, 9. This would be 3, 4, 5, 7, 8, 9. This could not be 6. Uh, hmm. I don't like going about that way. Okay, let's say this was 4. If this was 4, this would have to be 1, 3. And this would be 4. So there is no 1, 3 here. Okay. So this would have to be 1, 2, 6. This would have to be the 1, 2, and 6. Which doesn't work, right? Because we know, okay, so this would be 1, 2, 6. This would have to be 4 and 5, which would make this 9 and that 9, which doesn't work. So this cannot be 4. Can this be 7? Okay, let's maybe go about it this way. 8, 8, we have that. So this becomes 1, 2, 4. Therefore, this has to be So this is 4 with 1 and 2. This would have to be 6 with 1 and 2. So that'd be 1 and 2. This would be 9. So this would have to be 3 and 5. But that doesn't work because that's greater than 7, 8, or 9. So it cannot be 7. So this cannot be 7. Say this was 8. This was 7. This was 7. This was 9. This again could not be 6. So this would be no 7 or 8. This would have to be 1 of 1 or 2. This would be 9. 1 of 1 or 2 is here. 1 of 1 or 2 would have to be here. So this could be 3, 4. Okay, so this could technically work, right? This would be 6. This would be 6. This would have to be 1. So that's if it's 8. Right? Interesting. So this is valid. So this is one possibility. So we tried it if it's 8. Okay, so 7 is not possible. 8 is possible, in which case it would be like that, like we showed. So if this is 8, it can't be 6 anymore, so this has to be 6. And it would be with 1 or 2. Therefore, this could not be 1, 2, 5. Because then that would be 3, 4 here, and that would be 7, 8, and this couldn't be 8, 7, or 8, or 9. This would be 9. This would be 9. Right? So this would have to be the 9 here. This would be 8. This would be 1, 2. This would have to be 1, 5, because this cannot be 5. So it's 3, 4. This would be 6. You'd have 2, 6, 1, and this would be 1. And this would be 6. So that's if this is 8, right? Then you have 7. This was 9. So then this would be 9. Okay, that seems reasonable. If this is 9, this has to be 1, 2, 6, right? Because the 9 is eliminated from here, so this could no longer be 1, 2, 6. Let's see what happens if we make that 9. So say this was 9. If this is 9, this can't be 9. We know that this, we tried something similar. This is 1, 2, and 6. So this can't be 6. This cannot be 4 and 5. This cannot be 4 and 5. So one of them's 5, one of them's 4. Either way, they both have to be region sum, right? Right, because if you have a 5, I guess you could have a 1, 2. The other one would be 3, 4. That seems possible. Hmm. That seems reasonable as a possibility. Huh. It doesn't tell us very much. You have a 5 or 4 with a 3. So this is 8 or 9. Oops. This cannot be 7. This cannot be 7. It has to be 8 or 9. We know specifically what happens when it's at 8. This becomes 3, 4. This is 2, 6. This is 1, 5. This is 6. This is 9. That's 9. This is 1, 2, 6. This is 1, 5. Oh wait, that's kind of fascinating. What repercussions are there for this line then if that's the case? No, it could be 1. Hmm. So say again, this is 1, 2, 6. This is 9. Excuse me. Um, hmm. Hmm. Okay, let's try. Okay, so let's see. No, this can't be 4. We already knew that. This could be 5, I think. Can it be 5? Say this is 5. This obviously couldn't be 5. This would have to be 5. So this can't be 5. This can't be 5. This is either 1, 4 or 2, 3. The 6 has to be with 1, 2. So the other one would be 5 with a 3 or a 4. Okay, so say this was 2, 3. So the 6 would be with the 1. So this would have to be 1, 6. But then this would be 4, 5, and that would be 9 and 9. So this cannot be 2, 3 then. But what happens if we make that 1, 4? If we make that 1, 4, we have 6 with a 2. So this seems plausible. So again, this would have to be, this could not be 2, 6, because then you would have 3, 5, and that would be 1. That would be 9. That would have to be 9. So this would have to be 2, 6. This would be 1. This would be 9. Therefore, this would have to be, 8 and 8, which doesn't work. So it cannot be 5 either. So this can't be 5 either. It can be 6. We've shown it can be 6. But that's specifically when this is 8, right? If this is 8, this would be 3, 4. This would be 1, 5. This would be 2, 6. And that would be 6. Can it be 6 with this being 1, 2, 3? Interesting. Okay, so let's try that. Say this was 6 and we had 1, 2, 3 here. It would obviously have to be one of the 1, 2s here. So this would be 6. It cannot be 1 or 2. There's no 3s involved. One is 6 and the other would be 4 and 5. So that's not possible. Because a 4 and 5 would have to add up to 9, which doesn't work. So this cannot be 6 with 1, 2, 3. Can it be 7 with 1, 2, 4? Maybe. If this is 7, this would be 4. So it cannot have... Okay, so... First of all, then this would be 8. This would be 8. This would be 9. This would have to be 1, 2, 6 because this can't be 6. This is 7. So we would have 1, 2, 6. This would be 1, 2. This would have to be 3 and 5. But that doesn't work because that doesn't. So it cannot be 1, 2, 4 added up. What about 8? 8 might be possible. This is 9. This is 7. This is 7. This would be 8. So this could no longer be 6. So this would be 1, 2, 6. So the 6 is here. I guess that could be 8, right? So it could be 3, 4. This is 1. This is 8. So this is 1, 2, 1, 2. That does seem possible. So then this would no longer be equal to that. This would have to be a 1. Oh. Sorry, no, this would have to be 1. Ah, that doesn't work. Because we know the 1 is here. So it cannot be 3, 4, 3, 4 then. So we know then the 5 cannot be here. This has to be a 1, 3, 4 combo. This can't be 6. This is 1 or 2, so this is 5. Again, it could not be 3 and 5 here. Hold up. Okay, let's go back to where... Okay, so... Say... This was 1, 2, 5, right? 1, 2... This is 3, 4. This cannot be 7 and 7 because they both see that 7. This could be 1, and this would be 8. But then we figured out this can't be 8. This has to be a row sum line. So this would be 9, and this would be 1. But then the 1 gets eliminated. So it cannot be 1, 2, 5. So it would have to be 1, 3, 4. This is not 6. This has to be 5 then. Could it be 5, 1? Possibly. Then you would have 6, 6. Could it be 2, 5? This would be 7, 7 then. And you cannot have one. Okay, so hold up. 8 means this is 9. This is 9. So this is, yeah. This 8 means this cannot be a region sum line, because if it's region sum, this is also an 8. So no, we now know, good information, this is a region sum line. This cannot be a row sum line. We've just eliminated all the possibilities. We tried 6, we tried 7, we tried 8. Therefore, this is also a 6, 7, or 8. And it's the same digit as this, right? Now, we don't know what limitations there are. This cannot be 6. Again, if this is 8, this has to be the 6, so it's 1, 2, 6. This can no longer. Well, we didn't try this being 1, 2, 5. This would be 3, 4. Oh, but then this is 8, which forces that to be 7, which makes that 6, so that can't be 3, 4. This would have to be 3, 4, right? So if this is 6, obviously this is 9. If this is 6, obviously that's 9. So this is always 1 or 2 then, because it's either 1 with 3, 4, and that would be 6, or this is 1, 2, 6, and then this would be 6. So this is 1, 2 either way. So the 9 in row 6 has to be either here or here, right? Because either this is 1, 2, 6, and this becomes 9, or this is 1, 2, 6, and this becomes 9. So whatever, this cannot be 9. So we know these two are the same, which eliminates that and eliminates that. That doesn't really tell us much. Can't be here, can't be here. Oh, hold up. This has to be 6. Right? This sees these two, and this sees that one. So it cannot be 7 or 8. Therefore, this has to be 6. Interesting. So this can't be 3. This is 1 and 2. The 6 is with 1 and 2. Therefore, you always have a 3, 4 together. No, you have a 3 with a 4 or 5. Because of that, then, yeah. So say we had this being a 3, 5. Okay, say this was not 2, 6. This is one. This would have to be. This would be 3 or 4 with 5. The other one would be 3 or 4 with 5. But the problem is that if this was a region sum line, this would be 8 and 8. That would eliminate all possibilities of 8 there. So that's not possible. So the other one, you always have 3 with 4 or 5. If you have 3, 4 here, you have 1, 2, 6. So say this was 3, 4. This would have to be 1, 2, 6, and then a column sum line. If this was 2, 6, or 1, 6, this would be 3, 4, 5, but it cannot be a region sum line because if it would have to be 7 or 8 at least. Therefore, we know this is a column sum line. So this is 1 or 2. And this cannot be 5 because it would be 1, 3, and 5, right? So this can't be 5. This can't be 5, therefore this has to be 5. Therefore this is 1 and 5. Therefore the 1s cannot be here. Therefore we know this is 1 and that's 1 because you have to have a 1 with a 2 or 6 and a 1 with a 3 or 4. Therefore this is 8 or 9. So this has to be 7 then in both cases, right? One's 3 or 4, the other's 2 and 6. So this can't be 2 and 6. So this is either 2, 6 or 3, 4. So we have 8, 9, 8, 9. This one then has to equal that. What does that mean, though? I don't know. So if this was an 8, I think that means this also has to be an 8, right? If this was an 8, this would be... Okay, so say this was a row, right? Say if this was a row, these two add up to this, but it can only be 8 and 1 that add up to 9. Therefore, it cannot be row. It has to be a region sum line. So this is also a region sum line, which means this one is not. So this one is the same as that. Okay. So we've determined that. So this one has to be the same as that, which also is the same as that. So these 3 digits are the same. So this is a region sum line. It cannot have a 1. So it could be 2 and 7, 3, 6, 4, 5. So the 1 has to be somewhere along here. So these 3 are the same. This is either a row or a column. Okay, yeah, so let's do this then. 2, 3, 4, 5, no 5. 2, 3, 4, 7, 8, 9. 2, 3, 4, 7, 8, 9. This is also 2, 3, 4, 7, 8, 9. This cannot be 5. Okay. We're gonna make this pink. So pink is one of these 4. That's not very helpful. Um, Huh. Okay, so what happens if this is... Well, if it's a region sum, that seems okay. It is a little weird, though. Actually, what happens if it's a region sum? It would be at most 1, 6, which means this would have to be 1. So it'd be 1, 2, and 4. This would be 1, 6, or 5. Oh, interesting. So say it's 1, 6, right? Then you have 1, 2, 4. This cannot be 1 and 6. It could be 2 and 5 or 3 and 4. That doesn't tell us very much. Yeah, that's possible. This all seems possible. Hmm. Say it's a 1, 5. Then this becomes 1, 2, 3. This is either... It can't be 1, 5, so this is 2, 4, which doesn't work. Oh, this is interesting. This is interesting. Okay. Yeah, what does this mean then? So this cannot be 2, 4 because then this would be can't be 2, 6 and it can't be 3, 4. So we tried the region sum. 1, 5 does not work. 1, 6 does work. But the interesting thing then is column sum lines and row sum lines are very distinctly different, right? Okay. Let's remove the pink, actually. It's just distracting. So say this was a region sum line. The most this could be is 1, 6. So this would have to be 2, 5 or 3, 4. And you would have 1, 2, 4 here. Say this is a row sum line. This is again at most 1, 6. It can't be 1, 6 because then this would add up to 7. And we have a 7 here. So then this would have to be 1, 5, which would force that to be 6, which would force this to be 6. And this would have to be 1, 2, or 3. Right? So this would be 6, which would make this 3, 4, which would make that 2. So this would be 1, 3. Either way, the 1 has to be here. So that's for row sum line. And it cannot be less than 1, 5. So this would work, right? You have 2, 6, 3, 4. And then let's say you had column sum line, right? Well, then this would have to be 6. You would have a 1. This would be 2, 3. I guess this would be 6. And this would have to be 2 and 4, which doesn't work. So column sum line does not work. Row sum line does, right? Because we have 2 and 6, this would be 3 and 4. We'd have 1 and 5. Otherwise, this becomes 1 and 6. This is 2 or 4. This is 1, 2, or 4. And this would have to be 2 and 5 or 3 and 4. So we know this cannot be 1, 2, or 3 no matter what. Could be 6, could be 7, 8. No, there's no 6. This cannot be 2, 5 then. Okay, so the possibilities are, again, so this is 1, 5. This is a row sum line. This would have to be 6. This is 1, 2, 3. So this would be 6. So that's possible. This becomes 3, 4. So this is 2. This is 1, 3. So that seems fine. This is 2, 6. This would be 8. So this would be 8. This would be 9. You'd have 2, 6, 3, 4. This would be 8. This would be 8. No 5. So this would have to be 2 and 6. So you'd have 2. This is 6. So that's possible. Otherwise, this is a region sum line with 1 and 6, right? So we try 1 and 6. This would be 1, 2, 4. This cannot have a 6. So this would have to be 2 and 6. So we know this was 1 and 6. So this would have to be 6. This is 2. So this is 1, 6. This is 2, 6. So this is 9. This is 9. This is 8. This is 3, 4. This would have to be 3 and 4 also. So we know this is 2, 4, 2, 4. So either way, the 1's here. So the 1 has to be here. Oh, that's interesting. So if this was a region sum line, this would have to be 2, 3, 4. So we know the 1's here. We know the 1's here. So if this was 9, this was 9, this is 1, 6. So it cannot be 3, 6. This is 2, 6. 1, 6, 2, 6, 3, 4. So this would, okay, so this cannot be 4 either. So this adds up to 9. Right, 1, 6, this is 1, 2, 4. This has to be 3, 4 because this has to have a 6. So it's 2, 6. This would be 3, 4. So therefore this would be 9. Okay, so this has to be dark. Right, because it cannot, either way, it cannot add up correctly. Cannot be here, cannot be here. So one of these is dark. So say this was 1, 6. This is 2, 4, 1, 2, 4. This would have to be 3, 4. Which would make that 2. So this could be 2, 7. Cannot be 3, 6. Or it could be 4, 5. So this could be 2, 7. Cannot be 3, 6. This is 9. So this is 3, 4. So this would have to be 4, and that's 5. All doable. Hmm. 2 7 still seems plausible. Okay. This could be row. Can it be column? Hmm. Well, let's say we tried making it column, right? Then this would have to be 9. This would be 9. This would be 9. This would be 8. Ah, that doesn't work. So it cannot be column. It could be row still, or it could be region sum. Row seems fine. Oh. This can't be 6. Okay, so we know then this is 1 6. Because this can no longer be 6, right? We tried 1 5 here. Then that would be 6, right? So this is 1 6. This becomes 1 2 4. This can't be 6, so this has to be the 6. So this has to be 2. This is 6. This is 9. This is 9. This is 9. So this is 8, which means this is 1 3 4. So this can't be 9. This can't be 9. This can't be 9. This can't be 6. So it's 2 7 or 4 5. Therefore, this is 3 4 and 5. Hmm. So this is 9. Okay, so we can remove the black. We can remove the yellow. Okay, so this can't be 9 anymore. We're just tidying things up. Okay, so this is 2 7 or it's 4 and 5. Okay, so this is 3 4 5. This cannot be 3 or 4. Whoops. This can't be 3 or 4, which means this is 3 or 4. So this cannot. Okay, yeah, we knew that then. So no 1 3 4 6 or 9. So this is 2 5 7 8. This is 2 5 7 8 and 9. No 5. 2 7 8 and 9. It still could be rows. This is 3 and 4. This is 1 2 4. 1 and 6. 5 7 8. We have 1 2 3 4 9. So this can't be 9. Okay. So this becomes no 1, could be 2, no 3 4 5 6, no 7, could be 8 or 9. So no 6 8 here, no 9 here, no 9 here. We have 3 5 6 7 8. 5 6 7 8. No 7, 3 5 6 7 8. Can this be column sum line? Maybe. So that would make this 2 3 4. This would be it cannot be column sum line. So this cannot be column sum line. It's either region sum or row sum. Hmm. So this can never be 9, obviously. It can't be 8 either because it has to add up to one of those. 4 5 7. Can it be 7? If it's 7, it would have to be with 2, so it can't be 7. It could be 2 and 5, and that would be 7. It could be 3 and 5, and that would be 8. One of 3 or 4 is here. The other one of 3 or 4 is here. Okay. What about this? 2, 3, 4, 5, 6, 8, or 9. No 6 there. Cannot be column. Could be row. If it's row, this cannot be 9. If it's region, it can't be 9. If it's row, it can't be 8. If it's region, it can't be 8. And we know it can't be column anymore. Same here. This cannot be 8 or 9, right? It could be 7, though. Okay, so we actually don't know anything about this stuff. Okay, let's continue. 1 through 5, 7, 8. 3, 4, 5, 7, 8. If this is row, this is 9. This could be 1, 8. This would be 2, 7. Okay, so this could be 2, 3, 4, 5, 7, 8, 9. There's a lot of possibilities right now. So 9 cannot be anywhere here or here. That means 9 has to be one of those two. Again, this cannot be column sumline because this can't be 9. It could be row, it could be region. If it's row, that's where it's a little weird. If it's region, this has to be 4, 5. This is 2, 3, 4. And this is 9. Interesting. Not sure what that means. Right, so, okay, if, say it was region, right? This was 9, this is 2, 5, 2, 5. You have 6, 8, 6, 8. Oh, that's interesting interaction there. Then the 9 would not be here. Therefore, this is, if it's a row, it's a 7 at most. Which I don't... Yeah, this one would not be. So it cannot be row. Or, sorry, column. It can't be row either then, if that's the case. Wait, but can it even be region sum? I don't think it can be region sum either. Right? Because if this is 9, this becomes 3, 4 at most. So that's 7. I guess it could be 1, 2, 4. No, but then this doesn't add up to. Okay. So if the 9 is here. So say this was 9. That would mean this cannot be 9. So if you looked at a row sum line, This would have to be 3 and 4, but you can't have that because this would be minimum 9. If you had a column sum line, this would be 7 at most. But again, you can't have that because that's 9. If you have a region sum line, this would be 7 at most, and you can't have that because this is at least a lot. 15, 17. So the 9 cannot be here. So the 9 does have to be on this line. So therefore, we know this is 9. Therefore, this cannot be a region sum line. Therefore, we know this is a row sum line. And this adds up to 9 at most. So this cannot be 8. This adds up to 9 at most. So these are row sum lines. We know for certain. So, okay, so this cannot be a row sum line because then that would be 9. But this would have to be 9 also. And then that, so cannot be a row sum line. It could be a column sum line. This would have to be 2 and 9 then. So you would have 2 and 9. This would also have to be 2 and 9. Can it be a region sum line? 9 and 4. No, it cannot be a region sum line because 9 and 4 is 13. This is at minimum 17. So it has to be, it cannot be a row sum line, so it's a column sum line. And therefore, this has to be 2 and 9, I believe. If it's 1 and 9, oh, it could be 2 and 8. We know this is 9, so it could be 1 and 9, this could be 2 and 8. If it's 2 and 9, it's 2 and 9. If it's 3 and 9, it just doesn't work. And if it's 4 and 9, it doesn't work either. So this is a 1 or 2 and 9. Therefore, this is 2 and 8 or 2 and 9. So this can't be 2. So this can't be 2. This can't be 2. So these are columns again. So this is either 10 or 11. So this is 7 or 8. 10 or 11. So it cannot be 1. It could be 2, 8. It could be 3, 7. It could be 3, 8. Those are the only possibilities. Okay. So this is 1 or 2. Okay, so this cannot be 1 or 2. This is 3 or 4. One of these is 3 or 4. One of them is 1 or 2. Okay, so this is a row sum line. This is a, no, sorry, that's a column sum line. This is a row sum line. Interesting. So this adds up to 9 at most. Since it adds up to 9, we know there's one from 1 through 4. So it's either 2, 7, 3, 6, 4, 5. So there cannot be anything from 1 through 4 here. So this has to be 5, 6, 7, 8. This is 5, 6, 7, 8. This has one of 5, 6, 7, 8. So this is 2. If this is 2 and 8, this also has to be 2 and 8, and that doesn't work. So this has to be 3, which makes that 4, which makes that 3, 4. Interesting. This cannot be 3 or 4. It can no longer be 5 then, so this is 2 and 8 or 2 and 9. So this can't be 2, this can't be 3. So the 3 is here, so it adds up to 8 at most. This can't be 3, so this can't be 7. So yeah. So 7 has to be here. This can't be 7. This is 2, 8 or 2, 9. If this is 3, 8, this is 2, 9. If this is 3, 7, this is 2, 8. So this can never be 8. This is 3, 4, 5. Okay, that's interesting. So we have no 1, no 2, no 3, 4, 5, no 6. So we have 7 and 9, and 7, 8, or 9. This is 7 or 8. So this can no longer have 4 because it adds up. It could be. No, it cannot be 4. If this is 4, what does it add up to? It's either 7 or 8, but there's no 3 here, and it can't be 4 and 4. So this can no longer be 4. So this is either 3, 5 or 4, 3, 4. Hmm. Okay, what about this? 1 and 7 could be 8. 2. Oh. If this is 4 and 5, this has to be 2. So this can never be 2. Okay, so we know the 3 is one of these two. So if this is 3, this is 5. So this can never be 6. This is 2 and 5. So this becomes 6 and 8. Right? If this is 3, this has to be 5. Because there's no 4 involved. If this is 5, it has to be 2 because there's no 3 involved. So 5 is here either way. This can't be 5. So we have a 6, 7, 8 pair. This is 6, 7, 8. Interesting. So this cannot be 6, 7, or 8. So this is 2, 5, or 3, 4, or 3, 5. We don't know which. So this cannot be 6, 7, or 8. So it could be 2, 3, 4, 5. It cannot be 9. So we know the 9 is here. Okay. There we go. So this is 9, which forces this to be 2, 8, which makes this 3, 7. This becomes 9. This is not 9. This becomes 2, 8. So this is 7. We have 6, 8, 6, 8. This is 7. That forces this to be 9. This can't be 9. So this is 9. This is 1. This is 5, 1. This is 2. So this is 5. Therefore, this becomes 3, 4, 3, 4. This is 5. This has to be 3 and 4 then. So this is 4 and 3. 2, 8, 2, 8. So this is 5. No 1. Okay, this becomes a 2. So this has to be 4. This is 5. This becomes 1 and 4, which makes that 3 and 4. So this has to be 1 because the 2's here. This has to be 2. This can't be 8, so this is 6, 8. No 1 or 8. Oops. No 1 or 8, so this is 4, 5, 7. This can't be 9. This is a 1, so this is 6. No 3 or 5, so that's 6 and 8, which forces this to be 5. No 5 or 7, no 5 or 7. This is forced to be 6. This is 1. This cannot be 5. No 1 or 2. No 4 or 7. No 4 or 7. No 5. No 5 or 7. So this has to be 7 here. So this can't be 7. Okay, so this is 1 or 2. It cannot be 2. I guess this can't be 2. If this was 2, this would be 1. This would have to be 3, but that's not, doesn't add up either way. So either this is 1, this could be 2, 3. Wait, this can't be 1 and 8. This could be 2, 3, and that's 5. Can this be 1 and something? No. 1 and 3 adds up to 4. 1 and 8 adds to 9. So it's only 2 and 3 this way. This could be 1 and 7. And that would add up to 8. So this cannot be 8. This is 5, 7. Therefore, we know this is 8. This becomes a 3, 5 pair. So this cannot be 8. This is... Does that work? I guess, yeah. Well, we know this is 1 then, so this can't be 2 or 3. So this is 8, this is 7, this is 5, this is 2, this is 8, this is 3, this is 2, this is 8. This is 2, 8. No 5. This has to be 5. This is 8. So that's 6, 3, 8, 8, 6. This has to be 2 and 7. This is 3 and 5. So this is 3, this is 5, this is 2, this is 3, this is 2, this is 7. This is 4, this is 7, that's a 4, and that has to be 6. And that's a solve. Actually not too bad for a very hard puzzle. Obviously it took me a while to do. And it's now dark behind me, but I like the logic behind it, actually. It was very interesting. Very interesting having the sort of figuring out what these lines could possibly be. Was very interesting. Overall, yeah. And not too bad for, as I said, not too bad for a very hard puzzle. Some very hard puzzles can take a longer time than this. I think I've spent sometimes like 3 or 4 hours trying to solve a very hard puzzle. Anyways, I hope you enjoyed this solve. It was very interesting. It had a lot of little interesting elements to it. And I guess I'll see you next time on Frank Puzzles. Take care.